Good morning, afternoon, evening, and welcome. Allow me to get on my soapbox for just a minute. Our understanding of the Earth's environment and the negative impact of industrial activity on it raises concerns about the way we design, the way we build and operate today. Since 1700, the volume of goods traded internationally has increased some 800 times. And in the last 10 years, the world's industrial production has increased more than 100-fold. These dynamics pose unparalleled challenges for existing industrial systems and infrastructure devoted to the production, distribution, and consumption of goods. By 2050, the global industrial system is expected to double in its output, using 50% of current resources and generating 20% of current CO2. As a result, the industrial system will be central to the world's economy through the coming century. And if a resilient economy is really desired, this will only be feasible through a very efficient, low carbon, resource efficient approach. A breakdown of global CO2 emissions shows that the industry accounts for about 36% of the total. Over the coming weeks, we'll be looking at how we can soften in the energy and natural resource sector that blow, how we can make extraction, processing, and distribution better and more sustainable. So welcome to season 1, episode 1 of the XDI Experience live show, Energy and Natural Resource Sustainability. Let's do this. So I'm Andrew Sparrow. We provide people, process, and technology solutions for the entire product and manufacturing lifecycle. Today, we're looking at 4 parts of the value chain as a taste of where we're going deeper over the coming weeks. And our guest is Muthu Sivanantham, who is Energy and Materials Industrial Solutions Lead for Dassault Systemes. 25 years at Dassault, having served time across multiple industry sectors, transforming the way our customers design, produce, support, and maintain their assets. He's passionate about renewable energy and actively takes part in Dassault Systemes sustainability initiatives. So ready, let's get set and let's go.
Our lives are enriched by the energy and materials industry. From raw inputs for smartphones and infrastructure to fertilizers for food, it drives prosperity across the world. Progress stems from the minds of visionaries who challenge the status quo. How will they shape tomorrow when technology is accelerating change, strengthening competition, and a push to a lower carbon economy? They will put experience to work, engineering, constructing, and operating for ultimate efficiency and safety across the value networks they unify. They will imagine the future, find the breakthrough, harnessing new sources of power, making novel formulations, and turning waste into new opportunities.
Welcome, Muthu. How are you, my friend?
Very good, very good. Thanks a lot, Andrew. It's my pleasure and honor to share the stage with you and talk energy and materials, my favorite industry topic. And we're excited to have this collaboration between Dassault and XDI.
And sustainability is pretty dear to our hearts, and it's a pleasure to have you aboard on the show. So I know you're a bit of a veteran of these live shows / panels, and so I guess you're all ready for the Q&As to be coming in. Today, everyone, we're jumping into 5 sections. We're going to start with a macro perspective on the subject, and then we're going to lean into extractive industries, capital, facilities and life cycle, materials excellence, and lastly, asset management. Audience, please ask questions. There's a little bar on the side there where you go in, you ask those questions, whatever it may be, at any stage, please let them come in and we'll pick those up as we get towards the end of each and every section. So let's get the show on the road. Now, as much as we can stamp our feet and cry and demand massive changes overnight, and we all should go renewable energy and resources tomorrow, the reality is there are population increases going on around the world. There are standards of living on the way up in emerging economies. The demand for natural resources is set to increase greatly over the next decade. So we really need to be realistic and look at ways to drive ourselves towards a zero carbon footprint that is going to take time, because people take time to change. Muthu, give us an overview of what's going on from a macro sustainability perspective to combat these issues.
Rightly said, Andrew. We all have to have a carbon neutral economy tomorrow, but we need to keep our lights on, right?
Yep.
So from that perspective, energy and materials are at the heart of our changing society. The way the energy and materials are sourced, produced, used, are shaping not just our way of living, but also it's reshaping the future of the various industries. So for our energy and materials customers and companies, there are growing pressures to innovate and differentiate themselves from their competition and to do things in a more sustainable way. This is coming from societal pressures, governmental regulations, and additionally, these days, investor-led ESG push. According to data coming from Bloomberg NEF, sustainable debt recently surpassed $3 trillion with ESG-related investments. There's so much of activity going on and awareness going on from a financial front too. So we see the following key trends, as you kind of alluded to earlier. So the first trend that we are living today, going from fossil fuel-based energy sources to decentralized, low-carbon power generation.
What does that actually mean?
So that means going away from the traditional oil and gas based oil and gas only fueled economy into solar power, offshore wind, small modular reactors, always on nuclear power
wind farms in different locations. You've even got potentially this year, next year, everybody kind of taking their Tesla pack, taking in the solar power and selling it back to the grid. So as you say, very decentralized, very dispersed. Okay, I'm with you.
Yeah, Tesla and the Ford Lightning, right? So Ford Lightning recently announced the same. You said it right. And the second trend being moving away from commodity and specialty materials to circular, sustainable solutions. So more on that. It's a very interesting topic.
Yep.
And also moving away from the so-called extractive industries to sustainable governance of earth resources. Think of mining. Mining is here to stay, and it's still part of the sustainability equation. We'll see soon.
Yep.
And the other trend being, yes, mega projects are important. We are helping customers in this implementation of these mega projects, but there's also this trend of moving away from just one-off mega projects to repeatable, modular, and automatable smaller projects. And last but not the least, just thinking of assets, purely just looking at assets from an asset management perspective to how to take them to have a self-sustaining asset care kind of a philosophy going in the long run.
Just to step back for a second from a macro perspective, they say we need to redesign the industrial system and bring about a reduction of something like 25% on input materials and energy. I think it's 90% of materials that have been extracted are discarded, and we need to do something about that. We need to be using more benign materials for a kind of cradle to cradle concept. We need to be refurbishing and reusing long-lasting components. And lastly, we need to start mimicking and nurturing environmental niches as well. I mean, any thoughts on that macro perspective? Sure.
You hit the nail on its head when it comes to circular sustainable solutions there, like the cradle to cradle concept. It's all about the second trend I just talked about the circular and sustainable solution. That screams all sustainability, right? So thankfully, this cradle to cradle concept, it's not a dream, right? It can be achieved today. So the one example, one of the most the world's most utilized ubiquitous metal that's available in front of us, powering the economy, various parts of industries and economy, i.e. the steel, it still has a lot of growth left in it. That is one magic metal among few others that can be fully reused, remanufactured, recycled. I mean, they even say steel can be multi-cycled, and it's happening today. 95% plus percentage of steel that's getting into buildings without losing their physical properties are being reused today. So it's an excellent example. I mean, how we do that green is the next step. But today, as a metal, can be recirculated or reused. ArcelorMittal, a DS customer themselves, they are using also this concept called stelligence, which is like steel plus intelligence. So they are kind of thinking of the steel that's powering the infrastructure of in these buildings and in these big complexes. Treat them as a living mechanism. How you design them so that in end of life, how you disassemble them and how one steel interacts with the other and so on. So they are building it's a product line ArcelorMittal is building in this space. Right. That's 100% recycled. The other example, hold your thoughts on it, is redwood materials. Just hold your thoughts, and more coming on that later. Very interesting company.
Never heard of it. Okay.
Pioneering recycling of EV batteries, the much need of the hour.
Okay. Yeah. I want to go there on that one. Okay, good. So let's jump into the main show then. So let's go into the main event. We're gonna start with section 1, which is extractive industries. So extractive industries are responsible for half of the world's carbon emissions and more than 80% of biodiversity loss. Resources are being extracted from the planet now 3 times faster than it was in 1970. Now, the biggest surprise that hit me was the climate impact of actually pulling materials out of the ground and preparing them for actual use. All of these sectors combined together account for something like 53% of the world's carbon emissions, even before accounting for any fuel that is burned. So what can be done from a process and technology perspective to improve this sector?
Sure. Extractive industries, that includes mining, oil and gas upstream, exploration, oil fields, etc., are still integral part of the sustainability equation that we are talking about. So the global economy on one hand is headed on clean energy transition, which in turn is dependent upon innovative materials, especially minerals. So according to IEA, International Energy Agency, one of the most comprehensive global study yet, they really citing the overall needs for critical minerals could skyrocket as high as 6-fold by 2040. And enter Daniel Ergin, a Pulitzer Prize-winning energy expert and author from IHS Insights. He's predicting the demand growth for lithium is just going to go up by 4,300%. Sorry, it's a mouthful. And similarly with lithium, cobalt is going to skyrocket. Like in the growth is expected around.
So this is all driven by electric vehicles.
Electric vehicles, you said it right. This, of course, happening in the next 15 years or 20 years time frame. And he's predicting, what's called, we are kind of moving away from era of big oil to era of big shovels. Like tomorrow, we're not going to put 10 mines or 100 mines next to where you live in North America. We haven't built one since the 90s, but all these minerals, resources, Andrew, they have to come from where? From Mother Earth. So again, one other data point, to build like a 1,000 pound of electric batteries, we have to dig 500,000 pounds of earth to just achieve that. And then think there's a lot of shoveling left to do. So the idea is not to just move away from mining, and somewhere somebody has to mine, and these precious resources we have to just deal with them with utmost care. There's no other way around. So hence this renewed thinking of going away from just extractive mindset to how we sustainably govern these Earth's resources. Mm-hmm. So we need to manage these natural resources and plan on how to sustainably produce them.
So we basically need to understand geology in these sensitive environments while being mindful of the environmental impacts.
That's right. That's right. So model, manage Earth's natural resources, and carefully plan how to sustainably produce them. I think, as you can see in this, in this video too, like you said, understanding geology in a sensitive environment, it's key. And thanks to digitalization, all the leading mining companies are embarked upon these days. So we can model these mines, and we can do some resource estimation, material discovery, all virtually, before you end up really digging a lot of ground and digging a lot of earth. So that is one key, and many leading mining companies are doing this today, and we have sophisticated tools under our Geovia brand that can help mining companies, starting from raw material and taking it all the way through their operations. We can run such a digitalization, fully digitalized mines, for example. And it doesn't stop there. You can do similar things with oil exploration as well. And enter one other example called a mining iron ore company in Sweden called LKAB. They are partnering with ABB, Epiroc, Sandvik, and so on, and a few other companies. They've made this huge, biggest industrial project investment, using which they're not only digitalizing the whole operation, they want to achieve a reduction in the tune of like 2/3 of that country's carbon emission. So these are not minor projects. I mean, sustainable mining, green mining is a term, and Dassault Systemes is proud to be partnering with leading mining companies. And we not only provide tools, we really work with these leading mining companies around the world in how to be sustainably performing mining. So it also, the whole operation also has to focus on how we reduce emission, how we reduce wastage, and how we can make use of alternate energy usage when we do mining.
Got it. Very good. Very good. Awesome. So what are the extractive industry solutions that are being applied that you're seeing consistently? I mean, I hear of things like digital oil fields, virtual twins of mines, and then that's one. And then on the second level is that kind of data platform, collaborative platform, where you're taking in all of that visual and analytical and putting it all together in a single source of truth. Is that the entirety of the solutions that are out there right now? Yeah.
I mean, like you said, having a single source of truth data platform is key. I.e., in our solution set, we have the 3D Experience platform, and it can interact with your real-time systems and platform that's out there, like IIoT platform, getting signals, from these various devices, these various assets that are moving, the excavators that are running around in mines, as well as in a similar transportation equipment in oil fields. So it can receive signals in real time, and it can help. In addition to just doing your digital studies in advance, you can also run the operations in real time by tracking them and looking for any deviation and so on. Yeah, definitely.
Good. Okay, let's see what we got coming in. End of first section from the audience. Any questions? So what are the good practices and the technologies that can reduce the sector's footprint?
Yeah, it's a very good question. And, as we think of mining and as we think of EVs are not just for city driving and highway driving, right? Leading miners are employing not just electric vehicles, unmanned autonomous vehicles are at play. Equipment manufacturers like Caterpillar, like Komatsu, Volvo, all these guys are producing not just regular trucks, but they also have this autonomous capability in them. And it not only reduces carbon footprint, big other advantage is it improves the safety multifold. When you don't have to send a human for certain hazardous places and tasks, and a level of fatigue and other reasons, safety is also improved. So these are some of the good practices that's actually happening in the mining sector too.
Good. Okay, I think we got another question. Okay, so how can you remove the use of dangerous chemicals and acid drainage from mine sites?
Sure, that's a very important question, and it's a concern, in many people's minds, right? I think there are historical data that we have in the U.S., like even in the state of Pennsylvania and Ohio, from these abandoned mines, there's still, waterways are being, affected and so on. So the idea is to use a good tailing management and tailing planning. These are like the wastage that'll come out of once the mining is done, and they can also come from abandoned mines. So to have a sustainable governance of these mining operations is key. So had we done these digital tools like 2-3 decades ago, maybe, had we had this opportunity, maybe we didn't have so many problems today that we are dealing with. So having a sustainable way of thinking of how to operate these mines is also important. And so are the digital tools like this tailing management that can help. And Dassault, as I said, is very proud to be part of these international organizations and sustainable mining initiatives, how we could address the UN's SDGs, Sustainable Development Goals, in doing some careful mining activities. So having a sustainable governing tool is very helpful in managing these chemicals and tailings.
Good. Okay. Thanks, everyone. We can come back to further questions a little later. Let's move into section 2 now. Hopefully we didn't just lose you there, Muthu. Your camera went off, I think. We're going to go to section 2, capital facilities and their more sustainable life cycle. So these projects are increasing all over the world as economies modernize, be that reconstructing infrastructure in the already emerged economies and actually developing new infrastructure to the economic growth economies as well. So as a result of that, capital facilities need to improve design and build to protect people, the environment, improve productivity, achieve cost excellence, and transform operations. How do we design these things better for environmental, social, and governance? And what kind of technologies are helping us with this?
Sure. It's a very core topic that we address and we engage with customers worldwide today. So let me take a minute in explaining what are these, capital projects and facilities and portfolio around them. So these are like the capital facilities, and they can be modeled as projects all the way through their life cycle, right from the project initiation to building of new plants, and could be your chemical plant, your nuclear power plant, your oil refinery, your mine, and so on, and taking them to how you fabricate certain equipment assets and how you run these plants operationally, maintain them for sustenance, and how you go through the end of life decommissioning of them. So in order to do all of them in a single thread, digital thread on one platform, we need to have the right tools to model this information, bring in data from external, as well as model them natively. In addition, in order for your assets to perform well in real life, you need to have capability to design, engineer, and simulate them, having tools to do the same. And you need to have capability to construct, do some pre-walkthrough, and before you really commission something, have capability to do them all virtually. So we have a set of tools that address this full gamut of life cycle. And why we do this, and what are these mega projects, and why is having a single platform is key is, if you just take a step back to understand, per 2017 McKinsey report, only 20% of mega projects are successful. These mega projects are the ones that are $1 billion and above.
Yep.
And at least most of them are 1 year behind schedule. Look at the cost that will come up with. And 30% of them run over budget.
Yep.
And guess what? The engineering designs that come out of the early part of the engineering cycle, most of them, 95% of them are average or below average. So we need to also improve the engineering simulation and analysis in advance so that they perform better. And then guess what? New infrastructure relies on construction. And in construction, in the last 2 decades, we have had 1% of productivity growth. Compare that to contrast that with our repeatable or automotive and aerospace industries. Where have they leapt in the last 2 decades? There's so much of productivity improvement that can still happen in the construction space. That's common to us in energy and materials as well as to our sister industry at cities, territories, and construction. So in short, in order to manage these mega projects, you need to digitalize them and follow the entire life cycle as much as possible in a single thread, in a digital thread. And where we are helping today with these capital projects is like customers like EDF, Rosatom in Russia, Entergy Nuclear here in North America. They've used some of our tools in going through this full life cycle. So EDF, they have 3 programs live. And one of their key programs called ESPN, that stands for Equipment Under Nuclear Pressure. This solution is allowing EDF and their ecosystem of 14 companies like Framatome, Bureau Veritas, and so on to manage risk analysis on equipment under nuclear pressure, because these are heavy sensitive equipment in the nuclear industry. Mm-hmm. And the other collaborative effort that's happening even in these days and time is a new nuclear build coming up in Hinkley Point C in the UK. Yep. It's built by EDF and their provider, and engineering is done in EDF France. Now all of these activities, engineering, simulation, construction, and commissioning, all happening using our 3D Experience platform. And before you can commission a power plant, there's thousands and thousands of tests that need to be created and executed. So that's why it's key. And all these happening on one end, but on the other end, the industry is also transforming from how to be efficient here with the mega projects and go from one-off mega projects to repeatable modularity, so that we don't have to kind of go through this this huge cost issue if we encounter them.
Yep.
So what do you also see? It's an excellent case study done by one of our Russian customers called ASE. So they are an engineering service provider that helped Rosatom build a new nuclear power plant. And some of the tools that you see are maybe familiar with some of the Dassault Systemes users. So we start from an engineering bill of material to a CBOM or a construction bill of material. And you can visualize in a Gantt chart the various plans and steps you would perform all virtually before you build, any pipe or lay a brick. And you can not only just plan and schedule and visualize, you can do some simulation studies, things like, clash analysis. If you're removing a big vessel that you have to do part of commissioning as well as maintenance, mm-hmm. You need to have good clearance there. So it can be very costly once you put everything up on joist and then later you figure out how to go about doing that. Yeah. So on one end, we talked about capital projects running over time, cost, etc. There is this example where they have some concrete proof on $40 million that was saved in one nuclear build, and also the number of days they saved in executing this project, as well as reducing man hours, etc. Now, this program is really successful. They want to replicate this with their customers in the area, in Eastern Europe, Asian countries, and so on, where Rosatom is servicing.
Got it. Very good, very good. I'm going to jump to, we got a couple of things coming in on the LinkedIn live feed. A couple of things from Eco, I'm noting, picking up here, and Doko. This probably reverts back to extractive industries more than anything, but he said government should apply a restriction on wastewater treatment in the mining industry. Do you want to make any comment on that, Muthu?
Yeah. I mean, as soon as we talk about water, we know how precious is water. And some people, some of us in the Western part of the world, we take that for granted, whereas the other parts of the world,
not in California any longer.
Exactly, right, you said. And even that's closer to mining. And I'll give a small example. Maybe I was kind of going to explain this later, but I'll just give a small example here, just to get in the South American deserts like Chile and Argentina is where most of the lithium is coming from. That's powering our EV industries. Today, and just to extract on a day-to-day basis, because these are deserts. People there, they don't even have drinking water. But the only way we could, non-intrusively extract lithium is by pumping in billions and billion liters of water every year. It's billion with a B. That's the only way they go underground, subsurface water and pump them out. And guess what? 95% of the water evaporates into air. I mean, we understand it's brine. Nobody's going to drink brine, but you are kind of disturbing, the water system, water table that's underneath these deserts.
You bet.
And deserts. And that's what is required today, even to power with the EV industry and lithium supply chain. So that's why it is crucial. I totally agree with this comment that government should apply restriction, because now people in those Chilean and Argentinian deserts, they have proper water sanitation and drinking water. And so to other people.
A second comment from Eco also, HAZOP inspections. This relates back to your capital facilities. HAZOP inspection can prevent any accident that might happen in the future. Any comments on that?
Very, very good point, because part of our capital facilities information excellence solution, we have risk-based inspection. ASAP is one, but accounting for risk-based inspection is key. And we have certain process experiences that are really focused on how to account for risks. ASAP is one of them, and account for those inspection. And we also recently, on a related topic, we launched a fabrication excellence solution that deals with inspecting and surveilling on subcontractors that are building your assets and equipment. Because in regulated industries like nuclear industry, it is important to get the right quality of assets delivered. And as much of risks you account for in advance, it's good for the asset to perform in the long run.
Got it. Eco just responded to the water side of things, and I tend to agree with him, which was, digitalization, definitely using technology. But there's a comment that Eco made, which was lithium mining can use RO to get water from seawater. I guess that's a location issue as well. But then what's powering that RO plant? It just goes on and on. I don't know. Anything you want to speak to on that?
Yeah. So I just talked about the harmful setup. I mean, the wastage that's going on today, but still, it's better than getting in. The other way of extracting lithium today is to go break open the spodumene kind of rocks. They also come from rocks. Better yet, I think we'll probably see that today using materials excellence as one example. We could potentially come up with some innovative catalyst that can help with what is also called a common terminology in lithium mining today called DLE, direct lithium extraction. So that is like, do the same process, go to these Chilean deserts and extract lithium, but not pumping in billions of liters of water every year. So that there is a mechanism where if we can come up with this magic bullet of a catalyst that can help directly extract it and take the brine as such and process them in a power plant, mining plant, we can achieve that scale. I think reverse osmosis could be one other example. I think there are interesting examples floating around, which is key. because guess what? Lithium is traveling this 50,000 mile supply chain problem. I'll explain what that is, before.
Yeah, I know. Yeah, etc.
On the road.
Okay, we've got some other questions. I'm going to come back to those in a minute. But one thing that we've got in from a separate feed is, how does Dassault Systems help with LEED certification? I just know from a real estate background that I have for a number of years. So someone said, can we be LEED? I go, right, okay, that's another 15% on cost. What do you think on that?
Yeah. There are two parts, I would say. First of all, worldwide, most of Dassault offices and buildings and campuses are LEED certified. So whenever we build new, we always, sustainability runs in our DNA. So we definitely respect that a lot. There's also this renewed efforts where, in addition to, even as part of new LEED revision, they're also accounting for some carbon, I would say carbon footprint based calculation they are building into the LEED certification. So this is, definitely a real question to our sister industry, like the construction cities and territories industry, where they really go through these buildings getting LEED certified and so on. But I can tell you one thing, using the platform and its native tools, we can build and simulate building systems. So we can connect to various libraries. We have this tool set called Dymola that has capability to run various libraries, not just automotive simulation. We can also build building simulation, and you can do those studies. Platform, the 3D Experience platform can be definitely leveraged. But specifically about LEED, I would also get which process experience from our industries, like our sister industry, can help.
Yeah, I got it on the real estate side. Okay, just linking slightly into that, there's another question which I've got, which is, what are the practices to follow to create a living building, so zero carbon building?
Yeah, it all starts with materials, because as a materials and as an energy person, in the industry, starting with sustainable and recyclable materials is key, and also building them and then constructing them, keeping in mind how we dismantle and how we could sustainably plan their end of life. That's the other key. The intelligence I talked about, they are really building the steel. ArcelorMittal is building steel so that these kind of can be treated as a living mechanism inside a building. And prefab buildings are the next trend that we are seeing, where they use robots and 3D printed homes and components of the system, and they come and assemble them on site.
Got it. Within hours, days, weeks, etc. Very good. Okay, I think that wraps up capital facilities. I think it emphasizes that it's an engaging subject. It emphasizes that a lot of people want to be talking about that. We're actually going to be coming back to that in 3 to 4 weeks' time. Muthu, we're going to bring a guest in with you and talk more about it. So let's move to section 3 now. Materials excellence, material processing. So from commodity and specialty materials to circular, sustainable solutions. Please, Muthu, introduce this section. I know it's one dear to your heart, as to its environmental significance, the challenges, and the need for sustainability.
Sure. So why material excellence, right? So the topic and the industry that we are talking about today, the energy and materials, be it your petrochemicals, your chemical specialty chemicals industry, metals, oil and gas, and mining, what's kind of binding all of them, if you go to the source level, raw materials level, is coming up with innovative and sustainable materials, right? Let's say you want to build a new product or a chemical. In our lithium example, maybe a catalyst, a magic catalyst. The first barrier is to come up with coming down with the potential candidates, right? So the chemical space is huge, and the number of candidates can be overwhelming. So we can use tools like materials discovery to shortlist your candidates. But in silico, as we call, like in a virtual experiment, you can do thousands and thousands and millions of combinations of these tests without really getting into the testing part. Guess what? Once you get into the real-time testing, it can be costly, as you know, and building anything physical these days can get.
I get it. Cost is a big one, but there's got to be obviously a number of other challenges that are in this sector.
Sure. Yeah. So increasing R&D cost is one, which is definitely to build a new material. The cost of that doubles every 9 years. Huge cost. And knowledge reuse is poor. So less than 10% of new data that is created is ever analyzed today. Talk about tribal knowledge, right? Only 40% of, not only, more than 40% of experiments today are unnecessarily repeated. So when you have this giant global enterprise of various labs working together, because they don't have a single source of truth, they keep doing the same job again and again. So how about having single system where you can just, reuse what you've already done? That's going to be huge potential.
Over the last few weeks, we've been doing a lot of model-based systems engineering. Does that kind of fit within this sector? Because we always talk about it from a defense and aerospace, possibly automotive, but even introducing it in this kind of sector, does that work?
Yeah. Model-based system, here we are talking models from an atomic and a molecular level.
Exactly.
Right? Yeah. So, but it definitely applies, the scale is different. When we see model-based systems also helping with our capital facilities on the other hand, but definitely, yes. So going model-based is key, irrespective of the scale you're talking about.
But it's more data science, AI-driven.
Exactly. So now, we are getting into this next space. Okay, you're talking about these millions and so many atoms and molecules and combinations of ideas before you can come up with potential few candidates.
Yeah.
So you're talking growth of data on one side, proliferation of data on one side, and you're looking at all these material excellence combination on the other side. So it's the intersection of pure material science and data science coming together. It is this intersection that we call key to material excellence.
Got it. So combining that material science and data science, I understand. Okay.
It is this intersection that that is key, and as we can see in the accompanying example here, that some of our materials excellence solution, it's used by chemical companies as well as academia, and it spans across industries, and it uses some of our AI-rich machine language capable algorithms and data models. Okay. And we've been doing this over a decade or more. So some of our AI tools under our BioVia set of solutions is quite advanced in studying your atoms to molecules to even bigger systems, so to speak. So here it's an example that I was alluding to earlier. So we're trying to find a magic catalyst that will work with this lithium extraction so that we can minimize or even completely, as much as possible, eliminate the usage of water that gets evaporated as a waste. So we can do Monte Carlo simulation, various levels of molecular level simulation. As we apply to pharma and drugs, we can do the same for chemicals as well. And these advanced techniques like quantum modeling, data science, material science, guess what? Our customers need not be proficient in all of them. Nobody is, right? So what we do also, we can partner with our customers in engaging what we call as a OBE, or outcome-based engagement, where we just take the challenge, and we are actually engaging with some of the battery manufacturers too now in this methodology. In this business model, where we take the challenge, we use our own tools and produce just deliverable, like really result-oriented engagement with the customer.
I'm going to interrupt you quickly, but you spoke a few minutes ago about 500,000 or 50,000. I forget the number, but given that transport and mobility is arguably the greatest contributor to greenhouse gases, And we seem to now be all moving towards electric. I know there's the hydrogen argument and things like that, but I mean, let's assume electric for the moment. What are we going to do about these lithium batteries? You've touched on it a number of times already. We're in the materials excellent. What can we do to really change that game?
Yeah. I mean, like I alluded to earlier, there is this. We are posed with this 50,000 miles supply chain challenge, right? Because we mine them in Chile. The entire supply chain processing is happening in China.
Yep.
Whereas majority of EV companies and the consumers are on the western part of the world, and of course in Asia too. But the whole battery component has to take this real circuitous route before it can land up in any of our EVs.
Exactly.
So, and in the process of doing that, it's also consuming lots and lots of resources, like the 63 billion liters of water it takes to power these mines, mine lithium out of ground. So, at least in North America and in several parts of the world, self-relying supply chains is also a huge problem that's posing self-reliant supply chain. Let's say on the EV industry, the lithium batteries alone, if you take, it is actually it's a matter of setting up its own supply chain that are being formed. We never had this kind of supply chain in the past.
Yep.
We are challenged with this. So I kind of alluded to earlier, I'll jump right into that, called Redwood Materials. It's a company started by ex-Tesla people, like ex-Tesla CEO J.B. Straubel started this company. They're partnering with Tesla. Recently, Ford invested $200 million into this company, like 2 weeks ago, because everybody believes, because this company is claiming that they can reclaim 95% of lithium, and as well nickel from used batteries. So think of this. They are actually setting up a plant in Nevada, not too far from you, where they're going to be manufacturing cathodes. Because guess what? Over the years, cathodes and anodes inside a battery is 50% of a battery cost. And instead of going around the world and getting your battery chemicals, what if you can recycle them, right? Use materials excellence right there to extract these materials and put it back into a battery without suffering, without sacrificing any physical capabilities of the battery. So that's an excellent example that is very exciting happening in the EV industry.
We got a couple of questions. We've got another one from one feed which says, how can we make electric batteries more environmentally friendly? On the one hand, and then interesting, Eco again from the LinkedIn feed is saying research to look to new material like graphene could replace steel and concrete. I'm sorry, I thought that was related to something. This is back to construction. Do you want to comment on the construction one firstly?
Oh yeah. I mean, graphene is a very interesting concept that's holds a lot of promise. And I mean, if it can replace steel and concrete, nothing like it, right? So it's
that's the whole transparent building, isn't it? I mean, using transparent glass that's strong enough to hold a building and all these things. It's amazing. We did a previous show which spoke to the graphene side of things as well. So thank you, Eco.
Thank you.
I'm gonna come back to how can we make.
Coming back to that question, I mean, let me cite just two practical examples, right? One simple example, so consumer friendly and so close to consumers. You would have seen these faucet maker called Grohe. It's popular in Europe. You'll also see them in Home Depot these days. So they are making this cradle to cradle certified products. That they are just nothing but faucets made out of fully recyclable steel. So that's and they probably made sure the process of making them is also green. Mm-hmm. The other very practical example that has already happened practically is, it's been already implemented, is called an initiative called hybrid steel. And then enter our Swedish friends again. The same company I talked about, LKAB, which is a miner, they also partnered with a big steel manufacturer of Sweden called SSAB, happened to be a Quintic customer of ours too. They embarked on this journey to build something entirely green steel called hybrid steel. we talked so much about recyclable nature of steel, but at the same time, steel manufacturing, they are responsible for, on the industrial processes side, there's like 20% more carbon emitting manufacturers are coming from steel companies. So the metal itself can be recycled, but can you make the whole process green of building these steel, right? So that's what this hybrid steel is about. So where, as you alluded to earlier, even hydrogen is being used, hence the name hybrid, and it's fully green. And of course, hydrogen is yet to be break ground in transportation, but when it comes to industrial processes, we have had good successes in having hydrogen as a fuel. So hybrid steel is one other example where these environmental friendly products are really, making into the practical part of our economy.
Beautiful.
And by the way, Volvo is using this hybrid steel. That's the point I was going to make. They are on the road.
Okay, good. So that's it, materials excellence. Let's move into our last section now. We're going to move to section 4, enterprise asset management, perform with excellence. Now, having discussed capital facilities and life cycle, what are the some of the environmental impacts of poor performing assets, and what are some of the solutions to that?
Sure. In a really asset heavy industry that we are operating in, and also our plants and refineries and mines, if they are operating, people are pulling permits so that they can extend the life of them, because we got better in running them efficiently. Why don't we get another 20 years out of a nuclear power plant, right? So which is good and important. But how do we go from purely just managing assets to take them to this self-sustaining level of asset care, right? So we have a few solutions that in the maintenance, inspection, and shutdown and turnaround, those type of area, those processes that we have had very good success with around the world. And during COVID, pre-COVID, anytime people, outage experts always say, planning is crucial when it comes to successful execution of the shutdown and turnaround and maintenance activities, right? Because why planning is important. In a typical outage, in a typical maintenance plan for maintenance operation, let's say if you have 100 people, purely during turnaround time or this shutdown outage time, the number of resources you have to deploy in a plant just goes sixfold. You're talking 500, 600 people working for the same problem, because you have very small window. You got to get all your maintenance activities, planning activities, and schedules and tasks done to the T, so that you can be efficient as quick as possible. Because every day you extend, you are not making money running the plant or running your refinery or whatever. So the planning is so crucial. The idea is to do them all in one system where you can plan, schedule, execute, and learn as a closeout activity, so that you can do better next time.
I agree. That sounds good. But as we all know, there's always scope creep. There's always a few guys who've forgotten something who then introduce it a little bit late in the game. How do you handle scope creep?
Yeah, whichever projects you encounter, right? Whichever irrespective industry, scope creep is so common. And not only we have a good planning and scheduling tools inside our platform, we also have openness to import a plan or a schedule from external systems. Not only that, in real time, let's say you are managing your shutdown or your asset management work, we have tools to optimize them. Let's say, always there's some surprise comes up when you are executing a maintenance activity.
Yeah.
So right there, you need to have a tool that can readjust your schedule, and not only that, optimize it. So a resource is down, something else happened. Now I need to readjust it so that my key KPIs and my success and metrics are maintained at least close to what I planned. So optimization is key, and we can do them in the background while you are executing your plan.
Yeah. It's all down to the same thing, which is what the experts say. The planning part is often the most critical part of any successful maintenance or shutdown. slash kind of outage campaign.
Sure.
Got it. So what about the results in sustainable operations of assets? How can you get more value from that?
Yeah. So yeah, I mean, I'll talk when this demo or this video is going on. So basically, how to extend the value of assets that are running. Like we touched upon, the planning and scheduling is key. The more we do in advance, the more successful we can be in execution. So the planning can happen, right from multi-months to multi-years to on a day-to-day basis. So you can do multi-time based planning, right? So at various horizons. So not only that, once you get your plan done, thanks to our 3D context and 3D capabilities of our system and the platform and the tools, you can really relate your tasks and the resources to the asset you are maintaining, like you're seeing right now. In 3D, you can visualize them. And you get a better context of how your plants are operating or how they'll go through their maintenance process. And this is also talking about in real time. You just talked about there's a scope creep or a resource problem that came on. How you adjust as you are executing, because it is just not about what you planned or last month, and you throw that over the wall, and the foremen, the trades have to execute it. But things are always, you always thrown a wrench into the works. Every time.
Every project always is. There's always one.
Exactly. So now the maintenance, in addition, as it's explained here through this video, in real time, you can go from 2D to 3D, as well as to get some real time feedback as the foreman or the operator, they are walking around plants, and what they see, they can capture that in real time and feed that back to the system. So not only planning and scheduling is important at the beginning, then capability to optimize as you go. You can do them all in a proper context that you can understand without really walking onto a plant floor, and get these asset data in real time and respond to them. So that's right. It's a very interesting topic. We can go in much more detail in a.
We're going to get that chance. That's beautiful. That's great. Thanks, Muthu. I think we just got one question I want to pick up from Elena, which is a lot of times companies implement sustainable solutions that focus on the product's life cycle, design, concept, manufacturing, modeling, etc., up until final use of consumer. Is the digital thread able to manage the long-term waste as well?
Very, very good question, because traditionally, yes, we didn't plan and we didn't engineer our products thinking of keeping waste in mind. But the circular nature of this, nature of building sustainable solution definitely plays into that. Like you talked about earlier, design for maintainability. We used to call design for engineering, DFM, and design for manufacturing, all these terms that we use in other industries. Design for end of life and design for recyclability is becoming crucial. So right at the atom level, right at the molecular level, right at the materials level, if you start planning those and engineering those in mind, keeping those in mind, then we can definitely do that. So the circular economy, the circular sustainable solution will be key to achieve that.
Great. Good job. We're there. We're out of time now. Eco's coming in with another question. We're going to hopefully you get a chance. You can jump into the feed, Muthu, on LinkedIn, sure, and pick up on Eco's last comment as well. we could do that after the show. But
Sure.
thanks again. So next time around, we're going to be looking deeper into capital facilities and life cycle management with a guest, with Muthu joining us once again. Thank you, everybody. Thank you, Muthu. Have a great few weeks ahead, and we'll see you in 3 to 4 weeks' time. Thanks, everyone.
Thanks to Andrew. Thanks, everyone. Talk to you soon.
Okay.
Bye.